Good day everyone. So, sorry about my voice since di pa talaga siya totally okay. No? So, I'll be discussing again this lesson since we were not able to meet yesterday due to the suspension of our classes. Okay? So, when we are solving again conic sections like circles, parabolas, hyperbolas, and ellipses, we are just simply looking for the formulas of each values that we have, okay? So let us just have a recap. So here are the general formulas: the circle, the parabola, the ellipse, and the hyperbola. Okay, so please remember that these are the general formulas that we have for the circles, parabola, ellipses, and hyperbola. So next is a circle. So a circle is a locus of point which moves so that it's always equidistant from a point. Okay. So from the Pythagorean theorem, we get the standard form of the formula of the circle, giving us r x minus h, excuse me, x minus h squared plus y minus k squared is equal to r squared. So this is just derived from the general formula. If we try to get the general formula, we get here, okay? We get the final form of the general form of our circle, wherein a is equal to c and a and c shall never be equal to 0. Here are just parts of the circle. So we have the center, we have the radius, we have the chord, the secant, and the tangent. So the chord is a line segment that connects 2 points of our circumference, while the secant intersects our circumference, while our tangent only goes through 1 point of our circle. Okay, so that's the main difference of the three that we have here. So the diameter and the chord are also different since the diameter is twice the length of our radius, while the chord is not twice the length of our radius. Okay, so the length of the chord is shorter than the diameter. So we have here reduce the equation to standard form. So again, let's try to review this. This is just a review, okay, of the lesson last time. Again, if we are trying to solve this is just also similar from when we are solving ellipses and hyperbolas. Okay, so we have here x squared plus y squared excuse me, minus 2x minus 2y is equal to 2. So first thing that we need to do is to group all the x's and all the y's. So we will get x squared plus 2x plus y squared minus 2y is equal to 2. Then after this, we have to complete the square. We have x squared plus 2x. 2 divided by 2 is equal to 1. 1 squared is equal to 1 plus y squared minus 2y. So negative 2 divided by 2 is negative 1. The square of negative 1 is equal to 1, giving us 2. And we added 1 and 1 to the left side of the equation. So therefore, we need to add 2 on the right side of the equation, giving us x plus 1 squared plus y minus 1 squared is equal to 4. So therefore, our center, this is our equation. The center of this is negative 1, comma 1. Okay, since this is our h comma k. H comma k. And the radius. And let us try to first write the standard form. So we have plus y minus k squared is equal to r squared. Here is our standard standard form. So if you try to look at this, we will get our center is at negative 1. Negative 1, comma 1 is our h comma k. Wherein our r squared, our r is equal to 2. Okay? Or our radius is equal to 2. Since 4 is in r squared form. So I think that's it when we are solving circles. That's how we solve circles. Excuse me. let's see. So let's try to solve for number 3, I guess, since it has a different form. So for number 3, the center is at 3 comma negative 5, and the radius is equal to 4. Find an equation. So when we are doing this, it is very simple, no? We just simply write it in our equation. So we have x minus 3 plus, since this is our format, right? X minus h squared plus y minus k squared is equal to r squared. So all we have to do is just simply substitute all the values that we have. So we have x minus h, or x minus 3, plus y minus k, or y minus a negative 5 squared, is equal to r squared, or 4 squared. Simplifying this equation, we get x minus 3 squared plus y plus 5 squared is equal to 16. So this is already an equation of a circle, no? Since it is not specified in number 3, if we are trying to find the standard, or the standard form, or the general form, this would suffice, okay? But if you're looking for the general form of our circle, all we have to do is just simply expand all our binomials on the left side of our equation, giving us x squared minus 6x plus 9 plus y squared plus 10y plus 25 is equal to 16. Since the next thing that we need to do for the general form of our equation is that all the constants should be on the right side of the equation, giving us x squared plus y squared minus 6x plus 10y is equal to 16 plus 25 plus 9 is equal to 34. It will become negative 34. Yeah. Excuse me. Next, we will get x squared plus y squared minus 6x plus 10y is equal to negative 18. You can rewrite negative 18 to the left side. We get x squared plus y squared minus 6x plus 10y plus 18 is equal to 0. So now we have our general form and our standard form of our equation. So that's how we write the standard form and negative. Standard and general form of the equation of a circle. I think solving circles is much easier, and it's just almost the same for every conic sections that we have, and we're solving them. So if we try to find here, hmm, hmm, I think there's not much of a problem solving for circles. No, um, this example, example number 5, if I'm not mistaken, and find the equation of the line tangent to the circle. Okay, so if we reviewing this, okay, so please try to solve this. When we are talking about the line tangent to the circle, no, if it is a line tangent to the circle, remember that the tangent to a line, it should be that um, the slope should be the negative reciprocal. So for example, our slope is equal to m, and therefore the negative reciprocal, or m, the slope of the other line that is tangent to it, is the negative reciprocal of the original slope. Okay? So when you're trying to find for that, try to use this concept. So we have here, no, the slope of the original line here. If we try to look at this solution, find the equation of the line tangent to the circle. So first, what the solution did is, by completing the square, we first get the standard form of the circle to find our h comma k. Okay, and we have 1 comma 0. So we have here is that the line should be the line should be tangent to the line should be tangent to the line should be tangent to the diameter of the circle when intersecting the center and intersecting 1 comma 0. Okay, So the slope of the line, or I mean the equation of the line that we are looking for, is the line that is tangent to the diameter and is also intersecting 1 comma 0. So after that, we can solve for the slope first of this line of the diameter. Solving for the slope, we have a over b. In our format, it is also 4 over 3, or our a is our 4 on x, and our b is the 3 on y. So solving for it, we get the slope of the line is 4 over 3. To find the tangent to the line, we need to get the negative reciprocal. So therefore, since our original slope is 4 over 3, then therefore the next slope is negative 3 over 4. Since it is the negative reciprocal, or the negative inverse of the, excuse me, or the negative inverse of the fraction. Next, we move on to parabolas. So when we are solving for parabolas, no, we have to remember the parts of a parabola. So we have here the excuse me, the focus, the directrix, the axis, the vertex, and the latus rectum. So the focal distance, so the distance between the vertex to the focus. This is also the same distance between the vertex and the directrix. So this is just the derivation of our formula. So this is the standard form of our formula of a parabola. So x squared plus 4ay if it is upward, and negative 4ay if it is going downward. 4a is the length of our latus rectum, and this is the standard form of our parabola if our center is not at 0, 0. This is the standard form when the parabola is facing right or left, or it is facing along the horizontal axis. For ax if it is going to the right, and negative for ax if it's going to the left. And this is the standard form of the parabola if our center is not at 0, 0. So here's just a summary of all the formulas. So let's try to solve some of the problems regarding parabolas. So we have here, no, find the vertex, focus, equation of the axis, and equation of the directrix, and the ends of the latus rectum of the parabola. So let's try to find here the solutions for this problem. The formula that is not written in this table is that the length of the latus rectum is equal to 4a. So please remember this. So here we are tasked to find the vertex, focus, equation of the axis, and equation of the directrix, and the ends of the latus rectum of the parabola. So we have here, when we are trying to find this, so we have here our equation, x squared minus 2x minus 8y minus 15 is equal to 0. So now, since this is our formula, let us first try to isolate, okay, all that values that we have. So first, we have here, let us isolate all the x's and the y's and the constant on the right side. No, we are isolating the x since it is the one that has the square value. And as our observation, if it has the square value, it is where ours, it is our guide on where it is going to open. If it is squared at x, it is opening on the vertical side or on the y-axis. If the y is squared, then it is opening on the x-axis. So we have here x squared minus 2x is equal to 8y plus 15. So first that we have to do is to complete the square on the left side of our equation. So we have x squared minus 2x dividing negative 2 divided by 2 is equal to 1. Getting the square of the negative 1, we get plus 1 is equal to 8y plus 15. So therefore, if we added 1 on the left side of the equation, we have to also add 1 on the right side of our equation, giving us x squared minus x minus 1 squared is equal to 8y plus 16 plus 16. Yeah, there. So we can also isolate, or we can also get the value of, excuse me, we can get the value here. So we can further simplify the right side of our equation, giving us x minus 1 squared, getting the value of 8. We have y plus 2. So now we are tasked to find the vertex, focus, equation of the axis, and all the values that we have here. So if we try to draw our parabola, it would like somewhat like this. If this is our parabola, if this is our graph, I mean, and this is our parabola, solving for the center of our parabola, it is at 1 comma negative 2. So the center of our parabola, or h comma k, is at 1 comma negative 2. So since it is 1 at 1 comma negative 2, this is our 1 comma negative 2 approximately. So our parabola opens like this. Okay. Now our parabola opening upward since it is at the x-axis, and our value here is positive. Next, we're trying to find for the focus. So the focus is at a distance from our vertex. So we know that 8 here is our 4a. So if we try to write the standard form of our parabola, no? So we have here x minus h squared is equal to 4a, 4ay minus k. So we have here already our standard form of our formula. So this is our 4a, okay, our 8. So 4a is equal to 8. Solving for a, we have a is equal to 2. So now that we know that a is equal to 2, we can solve for our vertex. So we know that our vertex is at 1 comma negative 2, since it will only move upward. So therefore, we only have to add 2 on 1. So we have here our vertex is at 3 comma negative 2. And our latus and our directrix, since it is on the bottom side of our parabola, so we have to subtract 2 from 1, we get negative 1 comma negative 2. Next, we need to find the equation of our axis. The equation of our axis is just simply the point on on where it is lying. So here is our axis. This axis, or where it is cut into half, our parabola. So it is at negative 2, so therefore it is at x is equal to negative 2. Since our directrix, this point of our directrix is at negative 1 comma negative 2, and it is along the horizontal, so therefore our directrix is, the equation of our directrix is y, sorry, this should be, oh sorry, this parabola, if we try to graph it, sorry, it's 1 at 1 comma negative 2, sorry. So we have here 1 comma negative 2. So if it is positive x, it should be on the right side of our x and y axis. So we have here 1 comma negative 2. So here is 1, and this is our negative 2 here. So therefore this is our parabola. So it is just the same, no? No, there are no changes naman. 1 comma negative 2. Sorry for the confusion. 1 comma negative 2. So 1 comma negative 2. There. So here is our 1. Here. Here is our 1 and this is our negative 2. And I think that would fix it na. So if we try to get no the vertex again, it is going movement along the um y component. So if we add 2, no? So therefore, the vertex is at 1 comma 0. And our directrix, since it is on the bottom side of our vertex, it would go down. So we will have 1 comma negative 4. It is the point of the directrix exactly at the bottom of our vertex. Again, this is just a point that the directrix goes along. The next that we need to find is the equation of our axis. The equation of our axis, excuse me. The equation of our axis is the axis that cuts the parabola into half. So we have here, this is the half of our parabola. So therefore, the point at where it goes is at x is equal to 1. Okay? And this is the only point that it intersects. X is equal to 1. This is the equation of our axis. X is equal to 1. Next, we are trying to find the equation of the directrix. So the directrix, we know that one point of the directrix is at 1 comma negative 4. This is at this point. So therefore, since it is a horizontal line, its equation will become y is equal to negative 4. Next, the ends of the latus rectum. So to find the ends of the latus rectum, we know that the length of the latus rectum is equal to 4a. So from this point, we need to find two values of 2a. So this is the total length of our latus rectum, 4a. So from the center, or from the directrix, no? So from this point, no, we know that the latus rectum should be along our, sorry, I think this is very exaggerated. Our latus rectum, okay, so if it is measured from this side, it is also still 2a, no? 2a, there. So therefore, if we try to measure it, it should be on the, it should goes along our focus. So if this is our focus, oh, this should be the focus, sorry. Focus, yeah. And this is our vertex. The vertex is the somewhat the center of our parabola. This is the vertex, and this is our focus. Our focus is at 1 comma 0. So if we try to graph it, so this is at 1 comma 0, this point. So if we try to get the points or the ends of our latus rectum, it will just move along the x-axis. So we will just have to add along the x-axis as well. So we solving for 2a. So 2a is equal to 4. So if we add 4 on the x component, we have the points of 5 comma 0 and sorry, it should 5 comma 0 should be on the right side, and on the left side we have 1 minus 4. We will have negative 3 comma 0. So these are the points of the ends of the latus rectum. So again, when we are solving these kinds of equations, it's just again repetitive. Okay, when we are solving these kinds of equations. So let's try to solve this. No, these word problems of our that involves parabola. And here. A parabolic arc has a height of 20 feet and a width of 36 feet at the base. If the vertex of the parabola is at the top of the arc, at what height above the base is it 18 feet? So if I think this is very similar on what I've discussed and when we're dealing with ellipses, if I'm not mistaken, no? This is very similar and we are dealing with uh, hyperbolas, I mean, no? There's a similar or half the ellipse, yeah. It's very similar on one of the equation of when we are dealing with ellipse, no? That I've discussed in face to face. It's just almost the same. It's just that we are dealing with parabolas instead of we are dealing of in ellipses. So the equation that we are going to use is, of course, dealing with parabola instead of ellipses. So here, let us try to find this. So we are tasked to find on what height is it at 18 foot wide. So here if this is sorry for the drawing. So if this is our parabola, no, it is stated that if this is our parabola, it is stated that the length here, the width of the parabola at the bottom is 36 feet, and the height is 20 feet. The parabolic arc has a height of 20 feet. So this height of our parabola is 20 feet. So we are tasked to find if the vertex of the parabola is the top of the arc, at what height above the base is it 18 feet wide. So we are tasked to find if at what height is it at 18 feet. Okay, this part. At what height is it equal to 18 feet? So this one is our unknown. This height. Okay. So first, the first thing that we need to do is to determine the equation of our parabola. So again, this since it is opening downward, no, the equation of our parabola should be x minus h squared is equal to negative 4a since it is facing downward or opening downward times y minus k. So we all know that the vertex though, according to the problem, is the vertex of parabola is at the top of the arc. No, it is at the top of the arc. So we don't know if what is the value of our vertex. So we can assume that the vertex is at 0, 0. So why would we assume that it is at 0, 0? So if we try to assume that it is at 0, 0, it would simplify further our solution since our equation would become x squared is equal to negative 4a times y. So this would be further simplify our equation. So now the next thing that we need to find is a, no? So how are we going to find for a? We have the values here. We have the value of 36 feet and 20 feet, no? So if we try to find this, so looking at this equation that we have, or our problem that we have, since we assume that it is at 0, 0, if we try to get the number line, no? If we try to get the x and y axis, so let us try to write a small x and y axis. If this is our x and y axis, and it is at 0, 0, so therefore, all the values going down, if we try to get the values from the center towards the bottom part of our y-axis, so therefore, all the values here should be negative. So therefore, this 20 feet going down, using our number line, this should be negative 20. So we have on the right side, we have is equal to negative 4a times negative 20. However, since this is just simply on the positive side of our equation, no? Or the positive, since it is only on the what do I say this? How do I say this? On the x-axis, no? So we can find that it is on the center, okay? So we can divide this into two. So we have 18 feet and 18 feet as well. So since we are talking only about a certain point on our parabola, so for example, we are talking about this point, no? So since we are talking about this point and we have this number line axis, we know that this point is at 18, comma, negative 20. So therefore, we have here is 18 squared for our x. So now since we have these values that in our that's right, no, 80 naman. Yeah. So now that we have these values in our parabola, so we can now solve for our parabola or for our a, I mean, no? So we have 18 squared and negative 20, and we have negative 4a on this equation. So now we can solve for our parabola. So let us first open our calculator. So now let us try to solve for our a. So solving for a, no? So let us just first simplify our equation. So we can divide both sides by negative 4 and negative 20, giving us 18 squared, 18 squared all over negative 4 times negative 20 is equal to a. So we can solve for a. So a is equal to 18 squared all over negative 4 times negative 20, giving us a is equal to 4.05. So now we can now complete our equation of our parabola. Sorry, there. So now we can complete the equation of our parabola. So it has a different symbol now, sorry. So we still have here our formulas. So now, since we have our equation of our parabola, since we have a, we can now complete it. We have x squared is equal to negative 4 times 4.05 is equal to 4 times 4.05 times 1. So now, since we have the value of a in our equation, we can now solve for the height of the parabola at 18 foot wide. So again, it's just the same here. So if it is at 18 foot width, so we are solving for this point. So we can solve for this y value. Okay. So if we try to cut it again, so we have here 9 feet and 9 feet. So our x is 9 and our 9 comma our y value. Again, that's how we read it. Okay, so solving for this, we have our x is 9 squared is equal to negative 4 times 4.05 times y. So trying to solve for this, no? Solving for our y, we get that we divide both sides by negative 4 times 4.05, giving us 9 squared, sorry, 9 squared all over negative 4 times 4.05 is equal to y. So solving for y, no, we have 81 all over negative 4 times 4.05, giving us our y is equal to negative 5. However, this is not yet the final answer to our height, no? So again, the y that we find here is negative 5. It is equal to negative 5. Or simply, the length from this vertex towards this point. However, we are looking for the height, no? According to our problem, if I'm not mistaken, no? According to our problem, at what height above the base? What height above the base? This 18 foot 5. This is our base. Okay, this is the base of our parabola. So therefore, to find the height of this, we know that the total height of this is 20. So solving for this, we get 20 minus 5. So therefore, this is at 15 feet. Okay? It is 18 foot wide at 15 feet height from the base. So I hope you get the value, the logic behind it, no? Since this is the vertex, no? We're solving it from this point. Okay? So we got this y is equal to negative 5 from this point, not from the base. Okay? So since we got it from this point, and we solve this point from this point, okay? From the vertex towards this point, we get 9 comma negative 5. That is this at this point. So the length here, in a sense, is 5 foot. Okay? This is 5 foot. So since we know that the total height is 20, So we need to first find the difference between 5 and 20 to get this height. Okay? So I hope you get the logic behind it. So here, it is at 15 foot. So again, so I've discussed naman yung PT6 natin at face-to-face. So I'll try to give na lang din a short review for CO6. So I think, yeah, all was discussed naman for CO6, no? Even the problem solving. So I'll just give a short review for CO6 natin. So for CO6 ellipses, no, the main difference between ellipses and hyperbolas is that the equation is that the center should be positive, okay? Ito, in ellipses, it is positive, and for hyperbolas, no, we are dealing negative naman dun sa gitna natin. Where is it? Here, no, negative naman, yung standard form natin for parabolas. So again, same lang naman, no, major axis, ayan, minor axis. So please remember, no, that the major axis for the ellipse is the longer side, while the minor axis is the shorter side. So here is the connection between A, B, and C if we get the Pythagorean relations of them. Eccentricity, okay, eccentricity is equal to 0 if it's a circle. It is equal to 1 if it's a parabola, less than 1 if it's an ellipse, and greater than 1 if it's a hyperbola. So here naman is the formula. So it will just change, the numerators will just change if it is an ellipse, since the major axis will be a squared naman, no? It will still be a squared naman. However, if it is the major axis along the vertical, so therefore y minus k squared should be above our a squared. Same value. So here's the summary naman of our values. The length of the lateral rectum for both ellipses and hyperbola is 2b squared over a. So here are just some applications. So again, when we are trying to solve this, all we have to do is again to complete the square. Okay, just like in our parabola. Also in hyperbolas, no, we just complete the square to solve for these problems. So I think this was discussed naman, no, during face-to-face. And this was discussed naman during face-to-face. Here in hyperbolas naman, no, there were not given much word problems. It's just the simple problems involving hyperbolas naman again, no? And I've also given naman your written works for written works 5 and 6. So I hope you've answered them, no? Since these are also your review. I've already deployed them way back, no? Sobrang tagal ko na na-deploy yun. So I hope nasagutan nyo sila as your review for your PT tomorrow. So I guess that's it naman for ellipses and hyperbolas. This was all discussed naman during face-to-face. And repetitive lang naman yung questions regarding that. Okay? So that's all. So I've recorded this due to the reason for CO5 na maraming reklamo regarding the recording. So sorry for that. So I hope this helps you. And I guess nasagutan nyo rin naman yung written work 5. So I think there were not much difficulty in answering regarding parabolas, no? If nasagutan nyo yung written work 5. So I guess that's all lang naman for me for today. So I hope safe kayo lahat and good luck for your PT5, combined PT5 and 6 tomorrow. Thank you.